All right, welcome to the third lesson of chapter 12, and this has to do with the integration of vector valued function. Now the good news is, much like differentiation, integration of vector valued functions just means you take the antiderivative 3 times instead of taking the derivative 3 times. The bad news is you got to remember all those integral, I don't even want to call them rules, but integral procedures from last year, because if you remember, derivatives have rules. Antiderivatives, there really aren't any rules. It's strategies to help you find something whose derivative is the integrand, and that's pretty complex. So we are going to move along. So indefinite integrals, when you're taking the integral of a vector valued function, you take the integral of each of the components over the same interval. The result is a vector with x, y, and z components. AKA, if you integrate r of t, it's like you're separately integrating f, g, and h, the 3 components that make up r. So what does that look like? It looks like this. So if I take the integral of ti plus 3j dt, I'm really taking the integral of t dt, comma, the integral of 3 dt, and I'm just doing it basically within a vector. So the antiderivative of t, if you have a, we'll call it power function, t raised to a power, to take the antiderivative, you add 1 to the power, divide by the new power, and since this is an indefinite integral, you add a plus c. Antiderivative of 3 would be 3t plus c, and that right there is how you integrate a vector valued function. That's it. Can't solve for t, don't have enough information, can't make numbers, don't have enough information, that's it. So if I want to take the antiderivative of this next one here, e to the t plus sine t plus cosine t, the integral of e to the t is just itself plus c. The antiderivative of sine t, you have to think about, okay, whose derivative equals sine? Well, cosine's derivative is negative sine, therefore negative cosine would have a derivative of positive sine. And whose derivative is cosine? Sine's derivative is cosine, and I forgot my plus c, and then I put my bracket. And that's how you integrate it. Now, if we were going to integrate using definite integrals, if I take an integral and it's got definite integrals, it's got limits of integration, I just slap those limits of integration on each time when I go to take the antiderivative. So let's say we're going to do this. Let's say we're going to integrate from 0 to 1 the vector valued function given right here, the cube root of t plus 1 over t plus 1 plus e to the negative t is the 3 components. From 0 to 1, we just do each of these independently. So the antiderivative of t to the 1/3, I'm going to add 1 to the power, divide by the new power. I don't need a plus c because I have limits of integration. Then next, I have this guy, the antiderivative of 1 over t plus 1, which is like t plus 1 to the negative 1, if you want to think of it that way. That antiderivative is an ln. Now, if you don't remember that, it uses u substitutions to get you there. But basically, when you have 1 over a linear function, the antiderivative is always an ln. You can also think about it as this being the derivative of the end over the end. This is du over u. So the antiderivative is ln absolute value of u from 0 to 1. And then last but not least, the antiderivative of e to the negative t is going to be negative e to the negative t from 0 to 1. And then I plug in my limits of integration and subtract. So this is going to be 3/4 minus 0, which is 3/4. This is going to be ln 2 minus ln 1, and ln 1 is 0, so this is just going to be ln 2. And this is going to be negative e to the negative 1 minus negative e to the 0, so this is going to be like plus e to the 0, which is 1. And there's the value of that integral of a vector valued function. So Indefinite integrals, the ones up top of vector valued functions, indefinite integrals of vector valued functions lead to another vector valued function, because you still have values, you still have variables in it. Definite integrals of vector valued functions lead to just plain old vectors with values inside. Now, technically, you could have a definite integral that then leads to another variable. That can happen. But my point is, if you have an indefinite integral, you're always going to have some letters left behind. If you have a definite integral, you're most often going to have vectors with components that are numerical. All right, so find r of t for each vector valued function. So if r prime is equal to this, and we want to find r, we're just going to take the antiderivatives here. I've got to erase that. So we're just going to take some antiderivatives here. We're going to say, well, the antiderivative of t squared is, let's see, that's a power rule. So I'm going to add 1 to the power, divide by the new power. I'm trying to take an antiderivative, and I don't have any values to get me the plus c, so I'm just going to put a plus c here. And then this guy, another antiderivative, I'm going to add 1 to the power. I'm going to divide by the new power, which makes this a 1/4. And then I have another c. And then this guy right here, this is the integral of t e to the t dt. I have a product. Whenever you have a product and you're trying to take an antiderivative, what you need to be able to do with that is either use a u substitution, or in this case, you have to do integration by parts. So, integration by parts is the one that says the integral of u dv equals u times v minus the integral of v du. So, t e to the t, one of those is going to be u, the other one's going to be dv. How do you decide which? I tell my students this little trick, L-I-A-T-E. That trick tells you how to find u fast. So if you have a log function, that's u. If you don't have a log function, look for an inverse trig function. That would be u. If you don't have an inverse trig, look for an algebraic, which really stands for like x to a power. No algebraics, use a trig function. No trig, look for exponential. So if I want to evaluate this using integration by parts, what I'm going to do is say, well, I don't have any logs, I don't have any inverse trigs, I have an algebraic, I have t to the first. So u is going to be t to the first, and then everything else is going to be dv. Okay, so u dv, u means pick that guy, dv means everybody else, and then du is going to be 1 dt, and v is the antiderivative here, is going to be e to the t. So using this, the integral of u dv equals u times v minus the integral of v du. Here's half the antiderivative, it did it for me. Here's the other half, t e to the t minus e to the t plus c. The antiderivative of this is that, which is why I said in the beginning of this video that antiderivatives don't really have rules, they have strategies. And this is a perfect example of that. So the antiderivative of this guy is t e to the t minus e to the t plus c. Now, one of the things that is going to be helpful later on is these three c's, technically all are the same letters, so in many circles that would mean that they're all the same value, but they don't have to be. They are 3 random constants. So you can write C1, C2, and C3 if you'd like. You don't have to. You should know that those 3 C's are all technically different.